Hello everyone. Here we will discuss a topological problem which was asked in NBHM Ph.D exam. The problem is S is the set of all n cross n matrix A whose trace is 0. Then which of the following statements are true? S is nowhere dense in MNR, S is connected, or S is compact in MNR. Okay. How can we prove this? Okay. First result. See, if A is a subset of a metric space XD, then A is nowhere dense in X if and only if complement of A closure is dense in X. We will use this result to prove that S is nowhere dense in MNR. Okay. First, define a map F from set S to set of real numbers R as F trace of A. Then this F is linear map and every linear map is continuous. So this function F is continuous. Then S is inverse image of a 0 set. Since F is continuous and this set is closed in R, so inverse image of every closed set is closed. This implies S is closed. That means S closure is S. Since S closure is S, that means for S to be nowhere dense in X, we have to show that S complement of S closure, that means S complement is dense. We have to show S complement is dense. S complement is MNR over S. We have to prove that every point of MNR is either a point of this set or a limit point of this set. Suppose that if B belongs to MNR, and if this B belongs to this set MNR over S, that means if every point of this belongs to this, then we are done. Okay. Suppose B does not belong to this set. This implies B belongs to S. That means trace of B is 0 by definition of set S. In this case, we have to show that there exists a sequence AN in S complement such that AN converges to this B. How can we construct such a sequence AN? Let B is the matrix B11, B12, B1n, B21, Bn1, B22, B2n. Suppose B is this matrix n cross n matrix. We have to construct a sequence AN which converges to B. Let AN here trace of A B is B11 plus B22 plus Bnn is 0 as B is in S. Now construct a sequence An as follows: B11 plus 1 by n, B12 and Bn 1n, B21, B22 plus 1 by n, B2n, Bn1, Bn2, so on, Bnn plus 1 by n. Then this sequence An is converges to matrix B as n goes to infinity, and trace of An is not equal to 0 for every n. So the first option is true. S is no variance in MNR. Now for second option, S is connected in MNR. We will prove that S is path connected. So let A and B are two matrices in S and lambda belongs to closed interval 0, 1. Then trace of lambda into A plus 1 minus lambda into B is equal to, as trace is a linear function, so it will be lambda times trace of A plus 1 minus lambda times trace of B. As trace of A and trace of B is 0, as A and B belongs to set S, so this will be 0. That means for every A or B belongs to S, lambda A plus 1 minus lambda into B belongs to S. That means S is path connected. And every path connected is connected, so second option is also true. S is connected in MNR. Now for third option, is S compact in MNR? S is not compact in MNR. How can we prove? Take matrix A as n minus n and all other entries are 0. These are 0. This. Then trace of A n minus n, which is 0. This implies this matrix A is in set S, and as this A is unbounded, we can take n as large as possible. So S is not non-compact. That means C option is not true. S is not compact in MNR. Thank you for watching.